Welcome, Math 30-2 student. We're going to go work on prior knowledge on this lesson 3 on probability. So certain things that we're going to be tackling is investigating relationships, not just any relationships, but probability and odds. Very similar, but they are written differently, just giving you a heads up. Solve problems involving mutually exclusive and non-mutually exclusive. We'll go more on that in the web lesson itself. And solve problems involving independent and dependent events. And we'll go more in that in the course web lesson also. We're going to basically focus on this big one, probability and odds, because that's a grade 8 kind of concept. Grade 9, we also did a little bit on that, and grade 10 too. So I want to make sure you understand that concept. Moving on here, let's look at reducing fractions or ratios. Very simple concept that you learned back in the day. First, we need to know what's what. So looking at the following, we're going to be realizing this is considered to be a fraction, of course, because it's a piece of another piece. Hence the fact it's showing right here, there's 6 pieces and half of it's being used. So 3 out of 6 are being used. Hence the fact you can reduce that now to be 1/2. So keep in mind to reduce any fraction, as we know, we could look at 2/6. What do we do? What's common at the top? What's common at the bottom? They're both in the 2 times table. So you can divide by 2 on both sides, and then you get 1/3. The same thing if you took another fraction like 7/21. Over 21. Both of them are in the 7 times table, so divide both by 7. Both by 7. That's reducing this fraction, and then you get 1/3. So the difference in a ratio, though, it's to a part of. So 1 to 1 is what represents to the following. And what happens in that case is that we use a semicolon, a colon to indicate that it is a ratio. So if we took another example here, 3 to 9 can be reduced also by dividing both left and the right by 3. So you get 1 to 3 when you do the following. So reducing fractions are something very straightforward, but because we needed to do that, because in probability, we can write an answer in a fraction, in a decimal, or a percentage. In odds is only one choice in this case, that's the ratio. So let's look at the following formula. You've done this back in grade 8, where they really focused on favorable number of outcomes over total number of outcomes. So basically straightforward concept here. So if we make balls, let's do that, red balls that is, ones that are shaded, ones that are not shaded. Okay, so let's just make a whole bunch here. And I think I've drawn enough. So if my probability statement said the following, probability of getting shaded, let's just say it's S for shaded. So this is like setting up the probability statement. The S in this case means shaded, but you could have also had unshaded, so you could put a U. It's always basically the condition that you're going to be using here. So first things first, how many are shaded? 1, 2, 3, 4, 5. So 5. Now, total number of outcomes is the total number of actual balls in the bag. And you will realize it's 7. So, I always remember the total number is always going to be bigger. The denominator is always going to be bigger when you work on these. Now, that's probability. In odds in favor and odds against, a little bit different. First of all, there's a colon between each of them. And one is actually describing, if you say odds in favor, it's favorable outcome to, that's how, remember the ratio, to unfavorable outcomes. So what happens in that case is, well, favorable outcome of getting shaded would be 5. Now, unfavorable outcome would be 2. Do you see relationship related to the fraction we just dealt with? How about odds against? Odds against is always the opposite of that. So odds against of getting shaded would be 2 to 5, because favorable outcomes would be the 5 part. So keep in mind when you do odds in favor, odds against, always remember what it's asking. Odds against would be the opposite of what you're looking for, and odds in favor is what you're actually looking for. It would be the first value that's given. And then there's a colon, and then the actual opposite of it. So you should realize that when you add these both together, that is your denominator of your probability statement. Add these both together, the same thing. So let's move on, because we'll also need to do combination and permutations dealing with this in this topic, because we did it in lesson 2, now we need to do it with problems 2. So same formula always. Total number of possible outcomes is always in the bottom. Number of outcomes is always on the top. And you can write fractions in 3 different ways, as I said. A probability statement could be written in 3 different ways. A fraction, try to reduce it if you can, a decimal, and a percentage. So let's do the following. A committee of 5 people is to be selected from a group of 5 men and 6 women. What is the probability the committee contains 2 men and 3 women? So this is the extra bit where you learned from prior, is now we're going to have an indication of what the probability is with so many men and so many women. But you already could do the first part of saying that there is 11 altogether, 5 men and 6 women, and there's 5 people. So that's the first part of it. That's what's represented right here, 5 people, and in here 2 men and 3 women. So that would be either the top or the bottom. Well, I could say right off the back, it's the number of outcomes which the event is trying to occur would be the top. The total number is what we've done in lesson 2. So let's figure that out. Number of committee, so 11 times 10 times 9 times 8 times 7. Those are 5 people with the 11 right here. And then you do, well, 5 times 4 times 3 times 2 times 1. Hence the fact you're using a combination statement to make 462. So the next bit, well, you got to ask yourself. For the top of the fraction, 2 men and 3 women, you have 5 times 4 for the men, because there's 5 men, and then 2 times 1 because there's only 2 men you're using. So now for the women, 6 times 5 times 4, there's 3 women, and then at the bottom, 3 times 2 times 1. Well, to do that calculation, of course, you would actually have to do, well, 20 over 2 times, so 30 times 4, top of my head, calculate it out, 30 times 4, so 3 times 4 is 120. And then 3 times 2 times 1, which is 6. Of course, you could reduce right now or just multiply fractions by numerator times numerator, denominator times denominator. You get 12 at the bottom. You get, well, 20 times 120. 2 times 12 is 24. And then 2 zeros. Okay, so with that in consents, you get reduced fraction to be, well, how many 12s could go into 240, top of my head? 2. 12 times 2 makes 24, so then 2 zeros. So your answer is 200. So what is our final answer? Well, take 200, divide by 462. Okay, so 200 divided by 462 would be the probability statement, but of course you could reduce that, of course, to, well, take your calculator and calculate it, 0.463, and it keeps going a number, and you can put that in a percentage also, 46.3%. So keep in mind, you've tackled questions like this in lesson 2. So the only new bit is actually introducing the probability part of this. So that's one of the new bits that we're going to be looking at. Another question you could be tackling is a permutation kind of look here. So let's look at the following. The word counted has been spelled using Scrabble tiles. So how many letters are there? 1, 2, 3, 4, 5, 6, 7. So right off the back, we know we have to do something with 7. 2 tiles are randomly chosen one at a time and placed in the order in which they were chosen. Determine the probability the tiles are, well, A, C, and O. So we only have 2 options here. So that means it won't be 1 over 7. Will it be 1 over 14? That doesn't sound right either. So we have 7 words, 7 letters, and we need to either use a combination or permutation. Because order does matter, we should be using permutation. So in that case, you're going to be realizing you should be doing 1 over 7p2, which is 7 permutation 2, which is 1 over 42, and now you can write it as a decimal and a percentage. So what happens if you have both vowels? So how many vowels do we have? And they have to be both. Looks like we have 3 vowels. So what do we do in that case? Well, 3p2 would be at the top, and then 7p2 at the bottom. 7p2 stays the same because it's still saying 2 numbers, tiles that are being pulled. So in a nutshell, that's what we're going to be seeing in this lesson. Let's end off with a prayer here. And Father, Son, Holy Spirit on. Lord, let us always give thanks to what we have and the ability to learn more in math so we could succeed in future careers that deal with math. And let us get the probabilities for any questions that we do have. And if you need help, don't ever hesitate to ask your teacher. Amen. Father, Son, Holy Spirit. Amen. Hopefully that helps in this topic. And have a great